On this video, I'll do a small dual example followed by a large dual example. So I'm going to move at a little bit faster pace now. So hopefully you have the idea. So here is my example, and that is a standard minimization problem. So if I write the coefficients, then I would get 2, 5, 12 from the first inequality, and 3, 7, 17 from the second inequality, and then from the objective function I would get 21, 50, and 1. And then you know how to transpose the matrix. So when I transpose the matrix, my first row would be 2, 3, 21, second row would be 5, 7, and 50, and the third row would be 12, 17, and 1. And then I take these coefficients and I convert them into a dual problem, and here's my dual problem right here. And so the bottom row gives me the objective function 12y1 plus 17y2 equals p. And also make sure you state that you're maximizing that. And then the top two rows give me the less than or equal to constraints for my dual problem. 2y1 plus 3y2 is less than or equal to 21. 5y1 plus 7y2 is less than or equal to 50. And then don't forget, you always need to put in your non-negative constraints on the dual problem. Okay, now we have to solve this by the simplex method, which means I need to write the initial system of equations. And so I'm going to convert the first inequality to an equation by adding x1. Remember, I want to use x1 and x2 from the original problem. So I take 2y1 plus 3y2 and add x1 to it, and then that will convert it to an equation, so that equals 21. And then I'll take the second inequality, 5y1 plus 7y2, and I'll add x2 to it, and then that'll convert that to an equation, that equals 50. And then I'm going to move these terms across the equal sign, and that'll give me negative 12y1 minus 17y2 plus p equals 0. Let me just mention real quick that be careful that you don't try to move values across the equal sign when you're getting the coefficient matrix. Remember, when you do the coefficient matrix, you use the coefficients as they are, so you don't change their signs. It's only when you're solving the dual and you're getting the initial system of equations that you move these values across the equal sign. So anyway, that's just something I've seen students do that before. I'm just trying to make sure you don't do that. Okay, now I'm going to put this into a tableau, and so I have to have a column for y1, a column for y2, a column for x1, a column for x2, and a column for p. These kind of got misaligned here, but I think you know this goes with this column, this goes with this column, this goes with this column. Okay, so my objective function, I'm sorry, not my objective function. My coefficients are 2, 3, 1, 0, 0, 21 for the first equation. For the second equation, they're 5, 7, 0, 1, 0, 50. For the third equation, they're negative 12, negative 17, 0, 0, 1, 0. Now, the most negative indicator is right here, which is negative 17. And so then what I need to do is I need to figure out where do I pivot. So over here, let me show you what you're going to do. So if I take the 21 and divide it by this 3, I get 7. And if I take the 50 and divide it by 7, I get just a hair more than 7. I'll just call it 7.1, but it's a little more than 7. So since 7 is the smaller quotient, that would mean that the pivot row would just be this first row right here. And so the intersection of the pivot column and the pivot row would then be this number here, this 3 right here. Now on these examples, I didn't actually go through all of the row operations, so let me write them out for you here. So we have a 3 right here, that's our pivot element, and remember we want that 3 to be a 1. So what I would do first is I would multiply every value in this by 1/3, so just take 1/3 row 1, And of course that'll make that a 2/3, that'll make that a 1, make that a 1/3, and then zeros will stay 0, and 21 divided by 3 would be 7. So that'll give me that. But then after I do that, after I make this a 1, then I've got to use the 1 to eliminate the 7. So in order to make that 1 eliminate the 7, I'll have to multiply the row by -7. So I'll multiply -7 times row 1 and add it to row 2, and then that would give me this row. So I didn't actually show that, but hopefully you know now how I got this new row. I just took -7 times row 1, added row 2. And then to get the new row 3, I have to get rid of this -17. So then I would just multiply this new row with the 1 in it that I had and multiply it by 17 and add it to row 3. So again, you can do that on scratch paper if you want to go through these 3 row operations from this tableau and show that you'll actually get what I got here in this tableau. Alright, but notice here that I still have a negative in the bottom row. So I still have to continue here with my pivot process. So that's the only negative indicator. So that would be the pivot column. And then I have to take 7 and divide it by the 2/3. Well, 7 divided by 2/3 is the same as 7 times 3/2. So that'll give me 21/2 or 10.5. And then I have to take 1 and divide it by 1/3. And 1 divided by 1/3 is the same as 1 times 3, which is just going to be 3. So since 3 is the smaller quotient of these two quotients, then the second row is actually going to be my pivot row. So that's going to be my pivot row. And so where they intersect would be right here on that 1/3. And so now I'm going to have to do a second set of row operations, and I'll put them in here in a minute for you, but I'll do a second set of row operations where I will make this a 1 and then use the 1 to eliminate the number above and below it. So the row operations to go from this tableau to the tableau down here are written here, and so that's why I've got the little arrow pointing down here, so because I didn't have room to put it over here between them. So what I'll have to do is I'll have to multiply this row by 3, so that's row 2. So multiply everything in row 2 by 3, and of course that'll make that be a 1. And then after you multiply that row by 3, then you're going to have to multiply this row by -2/3 and add it to row 1, and that would be this row operation. -2/3 times row 2 plus row 1, put the result in row 1. And what that'll do is that'll get rid of the 2/3 and give you this 0 that I've got here. And then after you do that one, you're going to have to multiply this new row that I got. Remember, it's the new row I got that had the 1 here. You're going to have to multiply that row by +2/3 and add it to this row to cancel the -2/3, and then that'll give you the 0 here. And so that's the row operation, 2/3 times row 2 plus row 3. Now remember, you don't do these 2 row operations until after you've done this row operation where you've changed row 2. So anyway, if I do those 3 row operations in order, then I should end up with a matrix that looks like this, or a tableau rather, that looks like this. And this tableau, notice that this tableau has a solution of 121 for P, so that means that the solution for C in my original problem is also 121. But remember, if I want the solution for x1, it's actually in the bottom row, the bottom row of that column. So the x1 value is 1, and if I want the value for x2, it's in the bottom row of the x2 column, so x2 is 2. So the optimal solution for the original minimization problem is C equals 121 when x1 is 1 and when x2 is 2. Let me give you a bit of a caution here. For the row associated with the objective function, copy the coefficients exactly as written when you're getting the coefficient matrix, because this is not where we change the signs. I told you that a few minutes ago. Also, when writing the dual problem, be sure to do the following. Be sure you change from minimize to maximize and change from C to P, or whatever the variable is, change it to something else. Change the x variables to new variables. I use y's. And also change the greater than constraints to less than constraints. That's backwards. That should say change the greater than constraints to less than constraints. So I got that backwards. But anyway, change the constraints. And then don't forget your non-negative constraints. Now on this next one, I'm going to just summarize this one for you, just so you can see another one. Okay, so here is a standard minimization problem. You're minimizing with all greater than constraints. Okay, so by now you know how to get the coefficient matrix. So just write down the coefficients from the three constraints. Sorry, I hit the wrong button there. But anyway, just write down the coefficients from your three constraints, and then on the bottom row write down the coefficients of your objective function. And then you know how to transpose it, so get your transpose. And then from the transpose matrix, that's where you get your dual from. So remember, the bottom row is your new objective function, 16y1 plus 14y2 plus 12y3. And then the other rows are your constraints, so like 3y1 plus 4y2 plus 5y3 has to be less than or equal to 16, 2y1 plus 3y2 plus 3y3 less than or equal to 8, and 2y1 plus y2 plus y3 is less than or equal to 4. And then when you put all that together along with your non-negative constraints, you'll have your dual problem. And then of course, to solve your dual problem, you take your less than or equal to constraints. So I take each one of these constraints and I add the slack variables to them. But remember, we use the original variables from our original problem. So we add x1 to the first constraint, we add x2 to the second constraint, we add x3 to the third constraint, and that gives us the equations. And then we move these terms over here and change their signs, and that's how we get the objective function in the initial system. And then finally, we take this initial system and we put it in our initial simplex tableau, and then you just go through and start your pivoting process. So here we're going to pivot on this column because negative 16 is the most negative, and then we're going to divide 16 by 3, 8 by 2, and then 4 divided by 2, and check our quotients. And since 2 is the smallest quotient, we would pivot on this column, which means we're going to pivot on where the row and the column intersect at that 2. And then you're going to do the row operations. And I'll go ahead and write the row operations for you, but I won't go through them. So to pivot on this 2, you're going to multiply this row by 1/2 to make it a 1. Then you're going to multiply that by negative 3, that row by negative 3, and add it to row 1. Then you're going to multiply that row by negative 2 and add it to row 2. And then you're going to multiply that row by 16 and add it to row 4. So these are the row operations that you would do there. And then you should get this tableau. And then if you check, this is the most negative indicator on the bottom row. And if you check your three quotients here, 10 divided by 5/2 is 4. 4 divided by 2 is 2. 2 divided by 1/2 is 4. So you're going to see that this right here is going to be your new pivot element. And then to do the row operations there, you're going to have to do this set of row operations. You multiply row 2 by 1/2, followed by then multiply row 2 by negative 5/2, add it to row 1 to cancel the 5/2, then multiply row 2 by negative 1/2 and add it to row 3 to cancel the 1/2, and then finally multiply row 2 by 6 and add it to row 4 to cancel the negative 6. And then when you get finished, you notice you have no negative on the bottom row, so you have the final tableau. And so now you just look for x1, look at the bottom of the x1 column and you'll see it's 0. For x2, look at the bottom of the x2 column and you see it's 3. And for x3, the bottom of the x3 column is 5. And then since P is 44, then so would C be 44 for the original problem. So the solution for your original problem is a minimum value of C equal 44 when x1 is 0, x2 is 3, and x3 is 5. I'll finish this section on the next video with some application problems.